Okay, we've come down to our last sort of quadrant. This is analog input, and things are gonna get a little tiny bit more complex here, but we're gonna stick with the pattern. What you see on the board is just to help us sort of help the camera pick up the changes that we're gonna see from the analog sensors that we're using as an input. So let's go to Arduino and examples, analog, come on now. The first one we want to pick up is just called analog input. All right. There is an example page, tutorial, just like everything else. Now, this one has multiple types of input, including a potentiometer. We are not going to start with that because, one, I asked you to get a photoresistor for your kits, I think, or I may have. I'm going to start with a photoresistor, and then I'm going to show you how when sensors input pins have similar input pins, especially in analog sensors, they're interchangeable within the same circuit. So what do we need to get? Looks like a 10K resistor, 3 wires, and our photoresistor. So out here, you will see this is a photoresistor. It has 2 pins, and it has a little squiggly line on top of it. What this sensor does is it measures light, and it increases or decreases resistance in the circuit based on how much light it's getting. Another way to think about this is it is a resistor, but it has a variable value, and that value is varied based on how much available light there is. So it's one of these, but it has a range of values that can change based on light level. So let's go back really quickly to our circuit design. I'm going to zoom in on this part. A little bit of, it's not tricky, but we just need to get this correct. I want my photoresistor pins to be, actually I want them to be in 2 neighboring rows, and you'll see why in a little bit. Other than that, we need a 10K resistor hooked up to 1 leg, and in that same row, down from that leg from the photoresistor to a leg of the 10K resistor, in that same row, we want our signal wire, and our signal wire in this case is going into the Arduino board in the analog input section. So analog input is right here, and you can see there are 6 pins, A0 through A5, and it says right there analog in. Should be pretty simple. Back to our schematic. The other side of the resistor goes to ground, and the other side of the photoresistor goes directly to the power pin. So what this is doing is essentially it's that pull down resistor, but a signal is passing from the voltage into analog input. It's being read here, and it's going to, let's see, is that elsewhere in the circuit? Oh, I bet it's for the built-in LED. We'll see the effects of that. And again, that's why I have this extra LED tapped into pin 13, which is the built-in LED, let's see, pin. So I'm going to build that whole thing. I'm looking at my screen next to me. I'm not going to cut away. I'm going to put my resistor in, my photoresistor right there. I'm going to put my 10K resistor towards me on one leg of it. Carefully get it down in there. And remember, I want my photoresistor pins to be 2 neighboring pins here. No gap between those 2 pins. Let's see if that view is helpful at all. Yeah, not really. Let's try zooming in this way, like so. All right, they are not spread out. They are in 2 neighboring rows of the breadboard. Okay, I need to connect that to ground. What I'm going to do is power my pole power rail. I'm going to go to 5 volt. Into my power rail. I'm going to go from ground into my ground rail. I'm going to tuck these under the corner there just to help you see this all on camera. And now I'm looking over my shoulder at my reference image here. I know that the other end of the resistor needs to go to ground, like so. And I know that the far away pin of the photoresistor needs to go directly to power. And now, not too visually noisy, you can see I'm going to put my signal wire on the other side of the 10K resistor and into analog 0. I don't have quite enough wire to tuck that under. How's that? That's pretty good. Okay, that's looking good. Let's go over to the code side and upload our analog input sketch. And let's see what happens on the Arduino. Okay, code is uploaded. I see pin 13 and my external LED there are blinking. Now, what happens when I block some of the ambient light for the photoresistor? You can see that blink speed changed. So it's sort of like the blink code that we wrote for digital output. It's just blinking, and maybe you can remember what variable changes the amount of time that it blinks. It's the delay. And so now I can start to analyze this circuit and say, all right, what I'm doing here is varying the light level that's being read into analog 0, and it appears to be blinking an LED on pin 13 and simply changing the delay according to light levels. So let's go to the code. And indeed, we've got sensor pin defined as an integer variable in A0. So note this syntax. I need to say A0. There is a digital 0. I want to make sure that that says A0 as an analog input. LED pin is 13. And again, I have a sensor value. So in the setup, all I've done is declare my LED as an output. And let's get into the loop. So loop starts out by saying that sensor value is a function of analog read on the sensor pin. The sensor pin up above we see is A0. So we're saying sensor value is a variable that is reading the sensor pin. And let's start immediately by turning an LED on and delay it by sensor value. Turn the LED off and delay it again by sensor value. So what we see again is we're changing delay. We're not changing, it's not digital on, digital off. It's read the analog value and find out how long that value should make the on and off pause, so to speak. All right, now that's all well and good, right? I want to show you a couple of things. First of all, I mentioned that these sensors are sometimes interchangeable. So this is a 2-pin analog sensor that measures light. This is a 2-pin pressure sensor. So it's going to measure the amount of force applied on this cool little pad and turn that into an analog value that's read with the same piece of code. All I'm going to do right now is stick this sensor in those same 2 pins. All right. Man, I can't believe 311 is on again. When will they learn? All right, let's see what happens now. Aha, this is interesting. So I'm squeezing pretty hard here, and the blink is really slow. And now I'm gonna, as gently as I can, start to release some pressure. And as I release, the blink speeds up, okay? Same circuit, same everything, except different kind of analog sensor. Now, we could also try getting this finer tuned, but to tune it, we really need to understand its values. And to understand how to read the values, we've got to go into one of the last very cool fundamental functions of Arduino, and that is a serial monitor. So we're always transmitting and receiving data, but if we can't visualize that data, a lot of times we can't make full use of it. So let's go back over to Arduino. I want you to go to a sketch in the examples in the analog folder called analog in out serial. Okay, let's make this full screen. It's more or less going to use the same circuit design, except because it's an analog out, we need to move the LED pin over to, in this case, 9, but it could be any of those pins with tilde by them, the PWM pins. So I'm just going to bounce this over to 9. Done. Okay. So this should work out in the code. And my analog input pin is still A0, so I don't need to change that. I have an int global variable set up called sensor value and one called output value. Now, here's something new. Anytime we're using serial communication, we need to initialize that in the code. That is this line of code here. It's serial.begin, and 9600 is what's called a baud rate. So baud rate's cool. It's sort of like separating phone calls on a phone line. One phone call can be happening at one rate, and another one can be happening at a different transmission rate. And so they can happen simultaneously across the same wires without interrupting 2 totally different calls. I'm not sure that's the best analogy, but we'll get more into it. Let's look at the loop. So right now, I want to read the incoming value. So that's sensor value. I want to analog read the analog in pin. That's the pin on 0. Now, output value does something quite interesting here. It uses a function called map, super useful function, to take a sensor value. This is an analog value, and we should recognize that that is 0 to 1023. And we want to map 0 and 1023 to a value of 0 to 255, and that is an analog out, which is, again, honestly, a PWM function. It is not analog out so much as it is the Arduino turning things on and off at an insanely fast rate. So I want to analog write analog out pin analog out value. So what that's saying is, on my analog out pin, which is 9, I want to use this value that's created by mapping the sensor input to the digital PWM output, or the de facto analog output. Now here's how we see that in the serial monitor, which we'll open here in just a second. It's a built-in tool. It's right in front of us, actually. We say serial print And then in parentheses, I've got the word sensor equals in parentheses. That's in parentheses of its own, and then ended by a semicolon. The next line is serial print sensor value. Okay, so that goes back up to this sensor value being mapped from 0 to 1020, from 0 to 1023 to 0 to 255. And then the next line, it's going to say output equals, and then it's going to show me output value, which is the result of that function. Then there's a little bit of a delay here. You'll always see that delay in a serial program because you don't want to overload the computer's ability to process what's being read. So we slow it down just ever so slightly. I'm going to upload this code. Let's just look at, for starters, what we get on the hardware side. Okay, nothing initially happening, but very cool. When I just barely touch this pressure sensor, it is lighting up. And if I'm gentle with it, I can steadily increase the output as I increase the pressure. This is analog input going to analog output. Now, how do we know what these values are really doing? Let's go back to the software, and up in the top right corner, you're going to click on Serial Monitor. Okay, right now I'm getting this constant update saying that my sensor value is currently equal to 0, and my output then is also equal to 0. So this is the area where we said we want to look at values from 0 to 1023. This is the value being mapped from 0 to 255. So I'm going to squeeze, you won't be able to see this off camera, but I'm going to squeeze the pressure sensor just a little bit, and we get some values, very low values, as gentle as I can possibly be. And now I'm going to slowly increase the amount of pressure. I'm in the 100s, 200s, 300s, 5, 6, 7. I'm literally squeezing that as hard as I can, and I can get it almost to the 800s. I let it go, and it drops out. Very smooth. This is me squeezing, pinching it, letting it go. Again, and letting it go. So those output values are also getting pretty close. I can get to 200 or so, but I can't quite get to 255. And the truth is, I can't get all the way to 1023 on my sensor value. But I know that now because I can open this up. So I'm going to say I can get to 750. And the circuit is nice and stable, so everything, when I'm not putting pressure on it, drops to 0. Let's go back into the code and say I want to map my sensor value from 0 to slightly over 750. I want my values, my actual values, to still be within what I'm getting. So I'm going to say 780, a little bit higher, so that what I'm actually going to get is still within that range, not outside of that range. And I'm going to leave my 0 to 255. And it's going to be hard to see on the camera especially, but what I'm doing is I'm going to get an ever so slightly more responsive input from my LED, or from my pressure sensor. So I'm just barely touching that. And I know on the camera, like, it's really hard for you to see like how much the light is changing, but when you put this circuit together, you'll be really happy with it. So similarly, to go back to the code, I could say that I only want, well, no, let's do this instead. I want it to go from fully bright down to dark. So now what I have to do is try and squeeze it hard enough to turn the light out. All I'm doing is reversing those values in the map function. Let's give that a second to upload. There it is. Now our light should be on. Now as I squeeze, you should see it dim. And I think, oh, I can almost get it to go out. There, it kind of went out. Very cool. So this is an analog input, and it's mapping to also an analog output, which is PWM again. And so you have seen now analog input, digital input, and analog or digital output, whatever I didn't say yet, those things. And just as importantly, you have now seen where we open a communication line between the laptop and the Arduino, and we tell the Arduino what to send over to the serial monitor. So there's my 255, and now as my pressure increases, my light gets dimmer, and I can see that numerically. Very cool. I can actually get it down to I got it down to 0. So those are the basic tools for getting started with Arduino. This will take practice. You should dig into some further areas of interest. And I'm going to explain, last but not least today, after a short pause, where to reference the language to find things like for loops and the map functions, not just to find them, but to get a brief explanation of them and to learn their syntax. So quick break, and we'll take a look at the Arduino reference guide.